Joel, and I'm coming to you from the Sanjay Mortimer RepRap Festival. Thanks to Diamondback Nozzles. They're what's going to bring this booth visit to you. A big thanks to them for making it possible. This is James Bruton. Hey,
Hello.
man.
How are you doing?
It's good to see you. First time you actually get to see him on the show. James is a wonderful human.
Oh, okay.
I was going to say wonderful human.
That'll do.
An inventor, a modeler, someone who can take advantage of a small space and make many things possible, I think.
Yeah, I guess that'll do, yeah.
So James, where did it all start for you? What was your beginnings within like this sort of inventor-esque nature?
Oh, probably when I was a child, but if we start later in life than that. So in about 2004, I was looking online and I really wanted to build humanoid robots that walked along. I was like looking for an easy way to do this, and I didn't find anything, so I thought I'd work out how to do it and then I'd publish it. So I started, my blog and everything. YouTube, I didn't think it was around then. I had my YouTube account since about 2007. This is before 3D printing, way back, but I was using wood and skateboard bearings and all sorts of things I could find. So that went on for a while, and then, YouTube came along, and 3D printing became more accessible, and Raspberry Pis and Arduino and all the open source libraries and modules. Yeah, I started making serious YouTube videos in about 2012, and I've been doing it ever since. And I've been doing weekly videos up until last year. So, and here we are. Now, obviously, 3D printing makes it much easier to make parts quicker.
Oh, absolutely.
So that's why there's so much stuff here, and I do a video every 2 weeks.
Every 2 weeks?
Yeah.
Now, in order to do that, because my production schedule here on 3D Printing Nerd is we're making a video once a week, essentially. And what it takes in order to do that, but also have somewhat of a personal life, it's a bit difficult. And your projects are massive, absolutely massive.
Some of them are.
A lot of them are. I'm looking on the table here. It just boggles my mind seeing it in person. And one of the things I want to talk about, because I can see it in front of me, is Open Robot Dog over there.
Okay.
Can we go take a look?
Yeah, sure.
So James, this is the robot dog. This is your Open Dog, right?
Open Dog version 3.
Version 3.
Yeah, there's more like 7, but these were like the main versions and not the test legs and the other test dogs.
It breaks my brain because what you do in your videos, it's a very linear thought process of problem solving. But in order to get from that digital version of problem solving to a functioning robotic platform, how did this start? Do you sketch things, or is it digital exploration?
Well, bear in mind it was the 3rd version, but yeah, so there's already something else to work on and some experience. But the main thing about this was the cycloidal drive. So instead of having gearboxes with tiny gears, we've got these cycloidal discs, which is a 10-to-1 reducer.
Okay.
So the sort of first part of the process for this was designing this, then making a test leg with a couple of these, and then after that it was 4 weeks of making the whole mechanical assembly, and then putting the electronics in, and then doing the software, and that was it. So that was when I was doing weekly videos, and so that was basically 4 or 5 weeks if you count the cycloidal drive development.
That makes sense. The cycloidal drive, I remember seeing this, and I remember it's sort of, just the motion that it makes sort of breaks my brain here. And these aren't new, but but being able to make your own, was that a new thing?
Not really, but to make it 3D printed. So the whole thing can be printed in PLA, that's the key thing. So there's no fancy materials like nylon gears. Basically, because of that massive chunky disc, and all the discs are still PLA in this, there's 12 of those in here.
Still?
Yeah.
Wow.
So the plan was you could CNC them out of aluminium, but they're still fine in PLA. So it's basically like an internal ring gear, but with really big, chunky discs. So there's no tiny gears to snap, and that's why it's still fine smashing his feet into the ground.
As an inventor, as an engineer, one of the design constraints you have on yourself is being able to make things that work in PLA.
It was self-imposed so that it could, it's open source, so anyone can produce it with a basic printer.
What size printer do you need to make all the parts for
the biggest parts are these end pieces, or like the main chassis pieces.
Oh, these right here.
I publish step files rather than STLs, so it's the actual CAD, so it's a solid model you could cut up.
Oh, so you can cut it up any way they want.
So you could cut it up and put it on a bed quarter of the size, and then you could glue it about, put dovetails in or something.
Well, modern like Prusa Slicer has the ability to do the cuts and do auto dovetailing and stuff like that.
And then those pieces, but again, you could cut it up.
Are you going to let it walk around the show?
It depends how busy. It's quite busy in here. It's a bit of a tripping hazard. So I've got the batteries and everything.
Oh, perfect.
But we'll see.
Maybe tonight it could serve drinks.
Yeah, or maybe when there's less people, when the public.
Yeah, it could be.
It's the after show party.
Open Dog over there, open source, it's quadrupedal motion, right?
Yes.
Okay, but now we're talking about omnidirectional robotics, and these don't have legs per se, these have tracks, but is it a specific configuration?
Yes, so your normal Omni wheel is a wheel with lots of wheels around the outside.
Wheels on wheels.
So normally you'd spin it in one direction, these wheels will be passive. This one, they're actually active by doing this, but if you imagine that they're passive in one axis and active in the other, and then you'd have 3 of these 120 degrees apart, and you can move in any direction by, vectoring the motions.
Let me see that for a sec.
Sure.
So is this...
That's actually active, but anyway, I don't have
this is active,
I don't have a passive Omni wheel.
Big chunky gears is the PLA, right?
Yeah, sure. The mechanism
That's
in
really
there,
cool.
The mechanism in there is a twisted belt drive.
These are all belts. Oh my gosh.
Together to translate the motion round to the sensor, but...
I guess that's really the best way to do it.
So this was to make a robot that balanced on one wheel, so it can be like a 2-axis Segway.
Oh, I see. So it's here, and that white has to be active on this axis because it has to be able to push
But generally
itself.
those would be passive, so it would just slide in one direction.
That makes sense.
So this robot is very similar in that the wheels are driven in one axis, and these hemispheres are passive in the other.
Oh, just, wow. Okay, so they roll that way. Okay.
And then the only problem is when it runs on the peak of the hemisphere, we need the little wheels, because otherwise it gets stuck.
And these are passive as well?
Yeah.
Okay.
So this is 3 of those, which means that it can move in any direction that it wants to by, varying the velocities of those, or it can turn.
Oh, so
it's omnidirectional.
It's omnidirectional, but
with these special Omni wheels.
So then if this wheel and this wheel were turning this way,
yeah, sure,
then it
would
would
go,
push
and that
or
one's
pull
passive, or if
on passive. Okay.
To go directly sideways, then that goes that way, and that one goes that way, and that one goes that way. And that one goes 50% faster, and that makes it go in a straight line.
Ah, okay. And then that principle is actually carried across on something with tank treads.
So this is exactly the same, but the treads have little wheels that are passive in one axis, and obviously the tread is driven in the other axis, and that's the same thing, but a tank. And I made one of these big enough to ride on.
Do you have a favorite project?
The ones that do well on YouTube.
What?
So my most favorite recently is the Mobius Tank.
Okay, well let's take a look at that.
Okay.
Mobius Tank, Mobius strip. I've done this with a sheet of paper where you take it, you cut it, you do a half twist, and you got yourself
one twist.
A one-sided
That's it, yeah.
thing.
So if you follow it around, you end up on the inside, then on the outside, and then back on the inside. So it goes.
Do you watch the show Futurama?
Oh yeah.
Okay, so they had the Mobius race.
Yeah.
So this tank though, it shows off the Mobius principle of having that half twist.
Yeah.
Now, why?
So it was suggested in the comments of another tank video, possibly the Omni Tank, by a YouTube channel member who said they don't know why, but it might look cool, and I agree. And so I built one to find out. The only thing I could come up with was that you can have a whole track covered in one type of grip. So this time, one side is smooth, and the other, it's the same side, but one whole track has got grips on. So then you can have different driving surfaces, but obviously it's very hard to get in sync with them. But that was the only thing I could come up with. Obviously other people have said that the tracks would wear out less quickly because you use both sides.
Right. So
but then having the twist in is probably a thing that you don't really want for tracks that don't wear out because of the extra mechanical strain. But basically because it looks cool. And I make YouTube videos I want people to click on, and it's done very well.
Hasn't really done well.
It's done very well. Yeah.
Here. Well, that's just it. And I'm glad I'm glad you weren't like some sort of mid 15th century principle states that. No, you're just like it looks cool.
It looks cool.
It looks cool. But now, if we think to the future, then what are some ideas that you have of things to try out soon? Like what's in the workshop right now?
Nothing actually, because I've just finished the last video for the year, and now I don't know what to do. But what I want to do for next year is one of the big projects is going to be the new Omni wheel bike. There's going to be 4 mechanism wheels in a line, like a vehicle I can ride on.
Okay.
So it balances sideways like a Segway, but then it can screw itself along to travel forwards. So it'll be 3D printed mechanism wheels, 4 O drives, and an IMU, and the teensy or an Arduino making it balance.
That'll take
some weird
a couple
controls.
videos.
I don't know what.
I feel like that's going to take.
I think it's going to be a background project where I make all the wheels and everything in the background. Then I spend my 2 weeks slopping the rest together.
Okay, there you go.
So it'll just appear like any other regular, video. The whole thing probably.
This has been a joy, James. Like I'm so glad we know each other. But just being in the UK and actually going to a RepRap Festival that you're at with your stuff, I think that's special, and I hope everybody else gets to see a lot of this really cool stuff.
It's hard to take these on a plane and stuff, so.
Well, if you don't know who James is, I apologize, now you do, but you can go there to find out all about James Bruton.
So that's it, and
It is
xrobots UK on all other social media.
There you go. Well, if you made this far, you're awesome. Hug each other more, build more robots, and as always, high five. You want one?
All right,
Nailed it.
thank you.